March of 2025 says goodbye to Saturn, welcomes a total lunar eclipse, and continues to hang out with the rest of the planets. Hi everybody, I'm Rob, your last minute astronomer, bringing astronomy to normies and nerds with little time to spare. We'll start by talking about the big events, then highlight the naked eye planets, and then finish with the lunar phases and close encounters. All so you can plan ahead better than me. So the big event is the Pi Day total lunar eclipse. But before I get into that, just want to mention two other events super quick. One is the spring equinox, which is on the 20th. That is the astronomical first day of spring, even though meteorologically it kind of starts in the beginning of March. And you'd think that would be the middle of spring based on how much light is coming in, but that's just the way it works out. So that'll be the 20th of March. And also on the 29th of March, because eclipses come in pairs, there is a partial solar eclipse. However, you kind of have to be in Northern Europe to even catch a glimpse of it. So you might be able to catch it in Maine if you are, in the very, very northeast of the United States. You might just catch a little bit of it as the sun rises, but you got to be in Northern Europe. So I'm going to skip that one. So Pi Day 314, March 14th, we are having a total lunar eclipse in the morning of that day. It's a Friday, which will be nice. Maybe you can take that day off or something. But here's what I wanted to show you. I wanted to show you the times, exactly when it's going to happen, and talk about a little bit of the science around it. Now, if you have a sun and an Earth, there's an area behind the Earth that is in shadow, right? You'd be behind it, and all you would see is the Earth. You can't see the sun behind it. And that dark portion is called the umbra. And that's what we're really investigating here, okay? So what's happening is the moon in its orbit is perfectly lined up. Now, the moon's orbit is actually on a tilt. That's why this doesn't happen every month. Because it's on a tilt, you get the moon a little bit above or a little bit below the shadow. That's most of the time what happens. But there's two times of the year where they actually line up, and this is one of those times. Okay, so what is going to happen? Let me show you up here on the screen. All right, now I'm going to start this on the 13th because you've got a full moon. Okay? In fact, I'm going to center the moon so that we can kind of see what's going on, but it's going to be in the southeast, and as the night goes by, you're going to see the moon sort of enter into that shadow. Now, let me zoom in a little bit because the Earth's shadow, I told you about the umbra, but I need to tell you about the penumbra here. So there's a dark inner portion, and then there's a lighter outer portion. The penumbral part, you're not really going to see much. You might notice a slight difference if you look at the moon a lot. Now, the penumbral portion actually starts right around midnight, okay? But it's barely going to darken at all, okay? In fact, I think this does a little too much justice to it. Now, the best part, this is when it really starts, is the partial eclipse, and that is at 1:09 a.m. Now, 1:09 a.m. is when the moon actually hits that dark inner portion. It's at this point that you're going to start seeing, as time goes by, the shadows sort of munch away at the moon, and the shadow's going to follow this line right here. Okay? And it's just going to keep going and going. And this will last about an hour. And then right at 2, now it's still getting darker, but there's still a part of the moon that's totally brightly lit up by the sun. So it's not going to look quite as good until 2:26. 2:26 is when the totality begins. Not as impressive as the totality during a solar eclipse, but this is still super cool, okay? So the moon is now completely in the umbra. So if you were on the surface of the moon and you look toward the Earth, all you could see is Earth. You cannot see the sun. You might see a little corona around the Earth, but you're not going to be able to see any part of the surface of the sun. Now, what you will also see, if you were on the moon, you would see kind of a ring around the Earth in like a sort of orange, yellowish, reddish color or reddish hue. And that's because all of the light that's coming from, well, maybe not all, but the light that's coming from the sun has to go through that atmosphere, right? the Earth's atmosphere. And when it does, the nitrogen in the atmosphere scatters all the blues and indigos and violets and greens, and it scatters us. That's why we see a blue sky, because it scatters blue the most, the nitrogen in the atmosphere. The only light, the only part of that visible spectrum, Roy G. Biv, the only parts that can get through the atmosphere totally without being scattered are the reds, the oranges, and the yellows. The red's the most, orange is a little less, and yellow a little less than that. And so what you would see if you were on the moon is you would see this sort of glow of orange, reddish, yellowish around the Earth. And what you would technically be seeing is all of the sunrises and all of the sunsets on Earth happening at once. But now move back to Earth. You're looking at this. You're looking at the moon completely covered up. During totality, you are also witnessing all of the sunsets and all of the sunrises on Earth at the same time. It's just a little more indirect, right? Because the light bends toward the moon and it's filtered out, and that's what's left over on the moon. That's why we can see it. If Earth did not have an atmosphere, you would not see the moon during totality. It would be completely black. Would not be able to see it at all. All right, let's move on a little bit. The maximum eclipse is right at about 3 a.m. So if I'm at 3 a.m., that's as close to the middle as the moon is going to get. Notice it is a little bit above, so it's not the deepest eclipse, but it's still pretty good. And then right around 3:32 is when the moon exits the umbra, and that's when the partial part begins again. So now the shadow leaves the moon, or the moon leaves the shadow, from 3:32 all the way to 4:48. That's when the partial part is done. Now, again, it's still in the penumbra, so it might be a little darker than normal, but it's basically back to normal at this point. Okay. Now, some other things to look for. Okay. As the moon gets darker, you're going to be able to see more stars, right? Typically with a full moon, it drowns out some of the dimmer stars. However, in this case, it's going to be darker, so you can see more stars. I would use this as an opportunity to find Leo. Leo's pretty easy to find, even under bright skies. But you might also be able to find Virgo. It's a dimmer constellation, typically a little tougher to find. Might be easier to find because you have the moon as a reference point during totality. By the end, by the morning, by 4:48, when it ends, it's going to be off in the west. So this is very good viewing for us. It's basically going to be way up in the sky. It's not sunrise or sunset. Now it is during prime sleeping time, which is not so good, but that's what you get with astronomy. So again, make sure you get out on the morning of the 14th, starting at 1:09, the partial eclipse. 2:26 is totality beginning. Maximum is at 3 a.m. It ends, the totality ends at 3:32, and then the partial ends at 4:48. Let's get into those naked eye planets. Now, you might have heard about February 28th being the parade of planets and all of that, and that is pretty much true, because you could see even on March 1st, Saturn is down there, then there's Mercury, then there's Venus and Jupiter and Mars. So you can see all five. Well, Saturn's kind of gone. We're done with Saturn. It's not really there anymore, not really visible. But Mercury and Venus we might be able to see. Now, let's start, as far as sunset goes, let's start with those way down by the horizon over there. And Mercury and Venus, actually, you're only going to be able to see them for the first 2 weeks. So if we look here on March 1st at 6:30, which is basically sunset, and we keep going forward, you notice that Mercury is actually making a peak. It's coming up a bit, and Venus is setting. This is the time when Venus is going to basically go away, right? So let's talk Venus first. Brightest thing over there. Starts at sunset about 30 degrees above the horizon in the beginning of the month. It just dominates that sky. It's super bright, but it is going to nosedive over the next 2 weeks. So you look west after sunset, and one of the cool things is it's basically diving away. And by mid-month, we're not going to be able to see Venus anymore. But if we back up a bit, what we can do is take a look at Venus and check it out under the telescope. Okay. And if we zoom in, oh, there it is. It can be a beautiful, beautiful crescent. And as you get closer to mid-month, it gets even thinner and thinner as a crescent. So if you have a telescope or a set of binoculars, go see this. This is really cool. Okay. All right. Now let's back out of Venus and let's go to Mercury. I mentioned that is also visible the first 2 weeks. So here it is on March 1st, around 6:30. And as you go, it's sort of making this rise up, up, and then around the 12th, it's going to go right back down again. And it just so happens that on the 12th and the 13th, it's right next to Venus as well. So if you want to see these two, go out on the 12th or 13th at 6 or 7:30 at that point because of daylight savings time. They're going to be off there in the west. And that's only for the first 2 weeks. So get out there and see Mercury and Venus at that point. All right. We also have two more reliable evening planets, and that's going to be Jupiter and Mars. So let me go a little bit deeper into the night when it's a bit darker. Of course, we've been talking about Jupiter a lot. Now, Jupiter is up there. It's probably the brightest thing, aside from Venus, probably the brightest star up there. And it's right above the V of Taurus here. Okay. And then we have Mars over here in Gemini. You've got Pollux and Castor, the twin stars, making a triangle with red Mars over there. So they're going to be up there at sunset, and they're going to continue to be there through the middle of the night. Now, let's take a bigger look here. As we go through the night, let's go around, let's say midnight. By midnight, what's going to happen is Jupiter will actually be off in the west starting to set. And it does actually set around 1 a.m., but it's always going to be above Taurus's head there. Mars at this point is going to be closer to the west, but pretty much above us, kind of in the west-southwest area. And then these two, well, that's where it stops, okay? Because in the morning, well, what did I just say? I said Jupiter sets around 1 a.m. and Mars sets around 4 a.m., something like that. And then there's no more planets. But there could be some morning planets. But you have to wait until the last week of March. So let me go forward. Let me set it to sunrise. And you might be able to catch Venus way over here in the east. Because what's going to happen is Venus is going to make its morning planet appearance. And pretty much for the rest of 2025, it's going to be up in the east in the morning. And you notice, well, the sun's getting a little higher too. Let me go back to sunrise on March 31st. It's up there. It's not too high up there, but you might be able to catch it this last week. But if I go forward a couple months, you notice that it's getting further and further away from the sun. So it will be a morning planet for the rest of 2025. So again, remember, maybe Venus in the morning that last week. Throughout the night, you've got Jupiter and Mars. And at sunset, you might also be able to catch Venus and Mercury for just those first 2 weeks. Now, as far as the moon phases go, we start off the month with a week of evening crescents. In fact, on the 1st, we have a nice little crescent there. And then it's still a crescent until the 6th when it's the first quarter. That means it's visible until midnight. Then we'll have a week of evening gibbous moons until the 14th when we have that full moon and total lunar eclipse. Now, after that, you're going to have to get up later after sunset, sunset to find the moon, and you'll see some waning gibbous moons for a week. Then you'll have a last quarter moon on the 22nd. That's when the left half is lit up and you can't see it until midnight. Then we'll have a week of morning crescents and a new moon on March 29th. So if you're looking for the darkest skies, you're looking at the beginning and the end of the month. If you're looking for that eclipse, it's Pi Day. Remember that. Now, there are some lunar close encounters, and we start off even on the 1st and the 2nd. Let me zoom in here a bit. Okay. On the 1st, this is at sunset. Now, you do see Saturn. I don't think you're going to actually find that. But if we go a little bit later, you'll see that the moon is right in between Mercury and Venus, a little bit off to the left. I would probably use Venus as my guidepost. That should be the brighter thing up there, negative 4.55. No, the moon might be brighter. So find Venus or the moon, and then look down below for Mercury, about 8 degrees. That's less than one fist width, held at arm's length. And then on the 2nd of March, you'll see that it's above Mercury and Venus, and be easier to find. Now, if we zoom out, if you recall, the moon makes its path along the ecliptic throughout the month. And so it's just a matter of time until it gets near Jupiter. Let me go later at night so it's a little darker there. I'm going to say on the 5th and the 6th is when you're going to see Jupiter and the moon kind of hanging out together right there. You're basically on the 5th, it's to the right of Jupiter. And then on the 6th, it'll be to the left of Jupiter. And then you see Mars is nearby. It's not going to be too close on the 7th, right in between. But then on the 8th, it's going to be real close. In fact, only 2 degrees from Mars. So if you're actually looking at it, it'll look something like this. If you remember, we had a couple occultations recently. So now it's kind of getting off of that alignment. So that's on the 8th. Now, if you remember, there's no real planets for a while. So the moon's not going to get near any planets until the 26th. Now, if I go to the 26th and I get out there in the morning, so I got to go way through the night. There it is. Okay, the moon's over there. Oh, Venus is kind of nearby. Now, I don't want to go too deep into the explanation of how this alignment works, but you'll see the moon on, actually, let me go back one day to the 26th, went into the 27th. On the 26th, Venus will be up here bright in the east, and the moon's going to be over here about, I'm going to say 45 degrees away, like to the right. And this is kind of unusual. Usually they're more lined up vertically, but because of the season and other things, there you go. So the moon will be about as high as Venus on that day and only a few degrees above the horizon. Now on the 27th, it's even lower. Maybe you'll see it, but that's going to be a big challenge to find. And that's the sky for this month. If you find this advanced notice of the night sky helpful, please support this work by finding Last Minute Astronomer on Patreon. And don't forget to follow us on Instagram and Facebook. So till next month, I'm the Last Minute Astronomer, wishing you fruitful plans and clear skies. Music was produced by Deep Sky Dude and used with permission.